We will now continue our journey looking at the standard normal distribution curve, which is a special case of the normal distribution curve. The normal distribution curve can have any mean, any standard deviation, but the standard normal distribution curve has a mean of 0 and a standard deviation of 1. For example, we have this one right here. It turns out that when we have the standard normal distribution curve with a mean of 0 and a standard deviation of 1, that the numbers along the bottom number line become z-scores because they tell how many standard deviations a given data point is from the mean. The numbers are standard deviations. As such, they are z-scores. And those above the mean are positive. Those below the mean are negative. So these are positive, and these on this side are negative. And we can examine areas relative to these z-score boundaries. We can establish and select a z-score, which becomes a boundary, and we can look at areas relative to that boundary. For example, how much area lies to the left of a z-score of 1? Okay, we know that there's 50% here. We know that there's 34% between the mean and one standard deviation, which means that there's 0.840% of the area to the left of the mean. Now, what does that imply for us? Well, that means that 84% of the area lies to the left of a z-score of 1. I want you to see how I'm thinking about this. We identified and captured an area under the curve. We know what its decimal value is, and we can convert a decimal to a percent. We can always also say that the probability that a random data lies to the left of 1 is 84%. So we have 84% of the area to the left of a z-score of 1, and we know that we can convert that to a probability. We have a decimal, we have a percent, and we have a probability. And 84% means that 84 times out of 100, a random data will fall in this range. For example, how much area lies to the right of 1? Well, we know that there's 50% less than 0, there's 50% above 0. We know that there's 34% here, so the entire area is 1, minus this 50%, minus that 34%, means that we have 16% of the data lie from one standard deviation above the mean or lie to the right of that. Now, there are other ways that we might look at that. We might simply have ignored this entire area and said, okay, there's 50% here. 50 minus 34 is 16%. That means that we have 16% of the data to the right of a z-score of 1. The probability that a random data lies to the right of 1 is 16%, or 16 out of 100 times a random data will appear in that range. How much area lies between minus 1 and 1? One z-score, one standard deviation below the mean, and one standard deviation above the mean. Well, think about what you know. There's 34% of the data here and 34% of the data there. So we add that up, and it's 68% of the data lie between minus 1 and 1. Or the probability that a data will randomly fall between minus 1 and 1, a z-score of minus 1 and 1, is 68%. We're beginning to equip you with the thought processes that are required for you to master this material. You're making headway. What is a normal distribution? Well, it has centers around the mean and has certain percentages of areas between standard deviations and standard deviations. What is the standard normal distribution curve? That's the powerful one. It is the one that is a normal distribution with a mean of 0 and a standard deviation of 1. You keep climbing this ladder. You've got this. We're almost there. We're about ready to roar from the mountaintops and show the world what we have learned.